Good morning, mathematicians. We're back with the Galois Cohomology saga. It continues. Hope you're doing well. Hope you're ready to learn some Galois Cohomology. Yeah. Continues. Part 2 of who knows how many. Probably like 20 parts. Oh no, what am I doing? Yeah, 20 parts. I'm just guessing based off of it's like 70 pages. 75 pages. And we're at like page 10. We're probably going to slow down. But I couldn't find a copy of Local Fields by Sayre through my, not a digital copy, through my library, which is kind of wild. So we're just gonna keep going with this PDF, I think, and then maybe we'll switch over to a textbook afterwards. Because this textbook I was looking at, like, this PDF develops more of the basic theory first, and this textbook I was looking at, I think, did, spectral sequences on like page 15, which I've been thinking, perhaps this becomes, once we're through the Galois Cohomology saga, then I think we'll just sit down and compute a bunch of spectral sequences, because like I've said, I think the only thing I need to do to actually get it is to just spend like a couple hours sitting down and just writing down some examples. So why not do that on live stream? Well, Nibbleton, you can learn all of this, actually. That's the good news. You can learn all of this. Maybe not tomorrow, depending on your background. You might not be quite ready for Galois cohomology, or even this is just at the moment ordinary group cohomology. But you can absolutely learn this. In fact, by the way, I don't know your background, but I have a little series of videos. I think like 2 or 3 videos now talking about the semi-direct products of groups. There's another one scheduled to come out this Friday. And, if you know some undergrad math, then you might know some group theory. And so you might be able to follow along with my series on semi-direct products, which will eventually, I'm planning to have it intersect with group cohomology. You wish you could enter the experience machine. Well, you got to build the experience machine first by having enough experiences, Boris. Okay, so I think we were somewhere here, right? We have our classic free resolution. Free resolution, which of course gives us a projective resolution. And yeah, so typical stuff. I'm going to skip through it. They'll probably need to refer back to it because I always forget the right way to write out the formula. But yeah, this is just our good old tool that gives us these famous explicit realizations for our cohomology groups, which is fantastic. Okay. There's a massive latency issue. You see the comments here, and only after like 10 seconds. Yeah, normally it's not that bad. Yeah, I don't know what to do about that. If I close some stuff. Maybe if I close some stuff, we'll see if that helps at all. 25 seconds, damn. Well, yeah, that's weird. I don't know. Normally it's not that bad. So I don't know what to tell you. I guess we just lagging today. Boris, you weren't supposed to give away the location of my secret base. Ugh. Now I'm gonna have to find a new stellar body to inhabit. Come on, man. Okay, morphisms of pairs. Right. So interesting. Wow. That's actually really interesting. Okay, this is a bit of a side note, a bit of a tangent here. What am I gonna do here? You have some money problems, otherwise you would have gone to grad school for math. Well, by all means, I mean, yeah, I don't know your money problems, so you definitely got to fix those. But you do know that, I mean, grad school, you get paid a stipend, a very small stipend. You're still very poor, so I don't know. Maybe you've got like debt issues that you need to fix more immediately. How do I switch notebooks here? Okay. Here we go. But yeah, so you could go to grad school and feed yourself, but maybe you need more money than that. I don't know. But maybe there's a chance for you to go to grad school in the future. Yes, I keep forgetting to just get more money by doing that, Boris. Thanks for the reminder. Imagine what one could do with some multiplication. But anyways, I was thinking about, I mean, this is basically like the growth and deconstruction. But I was thinking like, okay, you know, we have representations, say, of some group, and representations, you know, and morphisms between those. But then I was thinking, well, what if I have a morphism of groups? Actually, okay, maybe I shouldn't get too distracted. This is the Galois Cohomology saga, but it is related to this. Oh yeah, we could, with matrix multiplication, we can make higher dimensional dollars, even higher dimensional money. Oh, you have a YouTube channel, Nibbleton? What's your channel? What's your channel name? Is it Nibbleton? I'd check it out. But I mean, so for example, what actually led me to this was essentially in my research, not quite this problem, but something like it. It was like there's a group, and there's, you know, a classification of its irreducible representations, say, and then there's another group, and it has irreducible representations, and we know that G and H are abstractly isomorphic. Okay, Nibbleton builds. I'm just gonna pull that open in another page here. Nice. 3 days ago. Hell yeah. Let's go give that a like, and then I'll come back and I'll watch it later. So, what was I gonna say? Yeah. But so the question is, and the thing is, like, this isomorphism was kind of like abstractly constructed. And so, of course, you can pull back, right? You can pull back a representation. So you could take, sigma I and get the, so you start with a representation of H, and you just by precomposing with phi, you then get a representation of G. Matrix multiplication, machine learning, deep learning, making monies. Yeah, yeah, yeah. And so the question is, which wow, ally. My sheaf playlist is fire. Still working through it. Loved it. Owe a lot to it. Do you plan on doing any applied stuff? Wow, ally. Well, not only do I very much appreciate $25. This is the first time I've ever received money on stream like this. So that's a very lovely, that's a very nice surprise this morning. Do I plan on working on any applied stuff? That's actually a good question. I don't have any plans at the moment. I don't have any plans at the moment, but, it is something that is arguably a weak point in some of my mathematics, and I would and so it actually could be a good excuse to teach myself some applied mathematics at some point. So I don't know. Is there a topic in particular that you were thinking of that you might be interested in? Ramen review when? I don't know, Boris. When you send me $25, then I'll review ramen. No, I'd review ramen for free. I don't eat that much ramen though. TBH. So but on the applied math front, yeah, I don't know. There's maybe something I've sometimes thought, like, maybe if I pivot to if I were to pivot to industry or finance or something, then maybe I would teach myself some financial math, some stochastic calculus on stream or something. More likely, though, which I'm sure you'll be happy to hear, is probably there'll be sheaf videos coming up. Right now I'm trying to write some papers / my thesis, but my plans are to work on some group cohomology. It's been on my mind to at some point finish my series on tensors. And then definitely I'd like to make more sheaf videos, probably talking about like locally ranked spaces next. But these are all, I don't know, it's kind of far away, so probably I'm just going to have some more filler content where I look at Vixra papers and say wrong things, because I said some wrong things in my last video. Yeah. Boris, some geometer peers in school who switched to ML. Also some profs who were doing relatively abstract stuff. Yeah. It is indeed very tempting to go to the dark side. I feel like I just don't know how. Well, I just need to make some coding projects. I should really make a machine learning algorithm that teaches itself to play Chomp. That really is what I should do, and put it on GitHub. Okay, so coming back to this group thing for a moment. So then I thought about, and I think this essentially just gives you the Grothendieck construction. I thought about considering the category of triples, where now, so you have all groups. So you have groups in the first component, vector spaces in the next, pi in the next, and then morphisms. So obviously, I'm not the first person to come up with this idea, because this comes up in group cohomology, but I'm so excited to see that it comes up in this group cohomology thing. I'm so excited to see that it comes up in this group cohomology thing, because this was something I was starting to play around with. I just sort of came to it, in my own way. And that has these intertwining operators. Sheaves plus category theory have really captured your interest. Currently working on a theory of epidemiology using sheaves in your free time. That sounds cool. Categoric Ali. I see. I could see, I could believe maybe there's like some local, right? Sheaves, local global phenomenon, epidemiology, local global spread of a virus, something. This is blasphemous, but what's the use of group cohomology? Well, that's what this whole series is supposed to be about. Well, where my mini series on group cohomology is going is about classifying extensions. So what are all the ways that you can build a group E out of two groups, G and A? We can take the direct product, but there's also things like semi-direct products. But what else is there? And I think in video 2 or 3, I already expressed that there's like various other interesting ways to build groups. I should not have reminded you, Boris, about you stealing the Chomp idea. Chomp is a game. I would just say go look it up. After the stream, and find like online Chomp game or something. Yeah. So, anyways, I spent some time thinking about like this thing as a category. Good morning, Paul Maurice. And yeah, I didn't really get anywhere significant with it, but I was thinking about like trying to encode various group concepts, and thinking about this as a fibered category, right? Like this it'd be like the category rep, like fibered over the category group, right? So where you just have projection onto the group factor. And I don't know, I just thought it was really cool. Also one thing I was thinking about the other day is that it's also really interesting that, so if you have a representation of a group G, then you can form the semi-direct product of G by that representation. And in fact, you get a functor. So if we take this category of pairs, a morphism in the sense that I highlighted above actually induces a morphism between the semi-direct products. And so this is actually a functorial process, and I don't know what to do or say about this, but it's like, I don't know, I think it's just really cool, and so I'm just excited to see this pop up in the group cohomology document. Uh, what do I think of Nassim Nicholas Taleb? Nassim Nicholas Taleb? I don't know who that is. Yeah, no, I'll have to look into him. I figured out that relatively... You're saying that I figured out the record? Or are you asking? No, I didn't figure it out. I just decided to move on. Well, that's the crux of the matter there, Nibbleton. That's the crux of the matter is Chomp. There is no optimal. There is no known optimal strategy. The belief is that it's we just have an existence theorem that says that player one has a winning strategy. We have no idea what it is. Certain boards, yes, but yeah. Okay. We don't have that much time left for a stream, so we should probably do some actual group cohomology. Yeah, I just don't have much expertise in game theory, so I don't know. It's unlikely I'll be doing game theory videos anytime soon. Have I heard of quantum functional analysis? I mean, I don't know what that would mean because quantum mechanics already has a ton of functional analysis. Quantum cohomology, wildly interesting. I mean, there's this funny thing where, things get inspired by certain things in quantum mechanics, and then the word quantum gets shoved in front of a bunch of everything. Like, there's the theory of quantum groups and quantum bases of some like types of Heck algebras and stuff, and it's like, yeah. So I don't know. I'm sure, and I mean, I'm sure quantum cohomology is interesting and all, but yeah. Langlands. You should go look up the Quanta video on Langlands. That should be, let that be your first introduction, I guess. Answering what Langlands is takes a very long time. Part of Shapiro lemma, which these notes don't clarify. Okay. These notes do touch on Shapiro lemma. Notion of W spaces in topology. C pi base, which, by the way, is still up here in my bookmarks. Quantum cohomology is really localization computation for rational curves. Interesting. Okay. Anyways, so I got excited about these morphisms of pairs. Okay, and then they're just explaining in detail how these morphisms of pairs induce maps on the sequences. Right. So the map from G prime to G induces the morphisms on the resolutions as such. Yeah, makes sense. And then you hum everything up. It's functorial, so we still get commuting diagrams. Yeah, makes perfect sense. Quantum functional analysis is a functional analysis in coordinateless space. Interesting. And quantum cohomology is just cohomology of Witten-Gromov invariants. If I ever found the time, you recommend to study it. Yeah. Maybe one day. There's just too much interesting math. I'm not complaining because I'd rather have too much interesting math than not enough interesting math. You've been hearing about the Langlands program. How do I see it in my field? Well, my field is the Langlands program. My field is the Langlands program. I work in the local Langlands program. So I'm not sure exactly how to answer that, other than by writing more papers. I do have videos where I talk a bit about my research. Some older live streams from a couple months back. There's some stuff about my research there. Yeah. Okay, Shapiro's lemma. Let's at least read the statement of this. Do you think a guy can do a full-time remote software engineering finance job and do a math master's? No. Not without one of those things taking a hit. No, that's not feasible. You could maybe spend a year of your master's not working to do your coursework, because there's a coursework requirement. And then if you wanted, you could like drag your master's on for several years and just work on it on the weekends, on evenings and weekends, while you did your engineering finance job. But it would probably take a long time. No, I wouldn't recommend trying to do that. Yeah. What did Paul Marie say? Or some... Yeah. Yeah, full-time job plus grad school is torture. I mean, grad school is like a full-time job. You found this channel through the Vixra video. You looked into that sketchy site and ran by some organization that gives heavy cult vibes. It's called Scientific God Inc. Oh, interesting. Wait, okay. Maybe I will feature that in the next video. Scientific God Inc. Vixra. Wow. Wait, owns and operates Vixra. What? Amazing. Okay, we're definitely going to be looking into that in the future. Okay, Shapiro's lemma. Let's get through it. Okay, we begin by considering a special case. We suppose that we have a subgroup and a module. Then we form a left module by co-induction from A prime. Given a G action, we set for G in here S dot phi goes to this map. Hang on. Okay, so A, what are they talking about here? Given a G action for S and G, we set this on A prime. Oh, they're just describing the G module action on here. Yeah. Okay. For S in here, the map given by this is a left G module homomorphism. Would thus give a right G action. So S dot phi above is the left action. Okay, that's just confusingly written. These notes are not good. Yes, I agree. Milne's class field theory notes. Okay, maybe we'll switch over to Milne. Do you get royalties for Vixra suggestion? We'll see how that video does. You suspect it runs Vixra through bots because the org is exempt from taxes. Thanks to owning Vixra. Really? Wow. I want to start my own bullshit thing. I want to use my math brain to scam people for money. Not really. Otherwise, I would have done it yet. When I get desperate enough. That would explain the sophisticated language and total lack of meaning or rigor. Yeah. That's the G action, giving that to that. Number theory is also great for that. Yeah. Yeah. Yeah, okay, well, let's take a look. Milne, class field theory. Maybe we switch over to Milne now. Let's see. Yeah, I don't know though. I mean, okay, class field theory would be interesting, but this is the Galois Cohomology. Series. Maybe, I don't know. Let me just go through what's coming up here. Let's have a little sneak preview at what we'll be looking at. Cohomology sets, homology, more resolutions, cup product. Yeah, if someone has a copy of Local Fields, a digital copy of Local Fields by Sarah, maybe get at me. We might switch to Milne, but get at me. Some Galois modules. Okay, this does go into Kummer theory towards the end. Ooh, Kummer theory of elliptic curves? I don't know, man. These notes do suck, but they do seem cool. There's not much difference, especially in the initial part. Okay. I mean, what do you mean, Galois Cohomology for abelian varieties? Aren't there, is this in Milne? I mean, but mind you, at this point, if we're talking about abelian varieties, we may as well just do class field theory. Okay. Well, I'll have myself a think about it. We'll see where I go. Yeah, libgen wasn't okay. I didn't check libgen yet, but the last couple times I went to go find textbooks on libgen, it wasn't working for me. I mean, I pay for all my textbooks, all of them. Yeah, okay, maybe we go over to Milne. What do you guys think? Milne's gonna be better. Maybe we go over to Milne. I'll look at Milne. If anyone, I'm having troubles with libgen because I never go there. If anyone can email me Sarah's Local Fields, the PDF copy, I would greatly appreciate it. But yeah, that's true. No one is looking. But this is where we're going to leave the stream for today. Oh yeah, look, here's a much better version of Shapiro's lemma. Okay, we're probably switching to Milne. Anyways, I'll see y'all soon. Go prove some things. I'm gonna go prove some things.